This video covers 2.8, solving linear inequalities in one variable. Objective 2, use interval notation. In Objective 1, we were graphing intervals. We were writing set builder notation. And now we want another way to express the solution set to an inequality. We use what's called interval notation. We now have three ways to represent all real numbers greater than 2. We've used the set builder notation to represent x is greater than 2. We've used the number line graph to represent all the numbers greater than 2. The third way is to represent it in interval notation. And it goes this way. On the graph, you see the left side of your interval is 2. The right side goes to positive infinity. So you write your left side first, your right side second, and then it's all about, do you include the 2 or not? Since it's just greater than, we include it and use the parenthesis just like in the graph. And when you go to infinity, infinity is not a real number, so you always use a parenthesis on infinity. It's not a real number, so you cannot use a bracket on it. So here's a few sets of numbers or intervals. This one is x is greater than or equal to a. Left number is a, goes to positive infinity. So we start at a and go to positive infinity. But since we're using a greater than or equal to, we include the a with a bracket. If it's greater than a, it goes from a to positive infinity. So we use a parenthesis on a and go to positive infinity. When x is less than or equal to a, this time the right side is a and the left side is negative infinity. So we go from negative infinity to a, and it's less than or equal to a, so we use a bracket. If it's less than a, it's the same exact thing, except for we use a parenthesis on the a instead of a bracket. And if you have the entire real number line, then we go from negative infinity to positive infinity. Left is negative infinity and right is positive infinity. And one last time, always use a parenthesis on infinity or negative infinity. They're not real numbers, so we can't include them. Now, if your interval is finite, meaning the left side is -2 and the right side is 3, then your interval notation starts at -2 and goes to 3. I'm including -2 and not the 3. All right, I like to graph these first before I write the interval notation. The interval from -2 to 0, we don't include the -2, but we include the 0. The left number is a -2, and the right number is a 0. We don't include the -2, but we include the 0. There's the interval notation. -3 is less than x, or x is greater than -3. We go to -3 on the number line, and we go everything to the right, but not including -3 this time. And so the interval goes from -3 to positive infinity, not including the -3, and we never include the infinity. The interval from -1.5 to 2.7, we're not going to include the -1.5, but we will include the 2.7. The left number is a -1.5, and the right number is a 2.7. Parenthesis on the -1.5, we don't include it. In the 2.7, we include that. So one more way to express the solution set to an inequality in interval notation. This concludes the video for 2.8, solving linear inequalities in one variable. Objective 2, use interval notation.